Find the asymptotes of the functions. All right, for example A, we have p of x is equal to 4x to the third over x to the fourth minus 1. And we're asked to find the asymptotes for the function, so first thing we want to think about is perhaps the vertical asymptotes. So for the vertical asymptotes, you just set the denominator equal to 0. So it'll be x to the fourth minus 1 is equal to 0. And that, of course, can be factored as a difference of two squares, right, initially. So we'll have x squared plus and minus 1 and 1. All right, so from here, the zero factor property says we can separate the factors and set them separately equal to 0. So we'd have x squared plus 1 is equal to 0, and x squared minus 1 is equal to 0. That will lead us to the idea that x squared is equal to negative 1, and this has no real solutions because if you square something, it doesn't end up being negative unless the value is I, right? An imaginary number. So we don't have to worry about that one. That's not going to give us any places where we have undefined points in the function. So we don't have to worry about any vertical asymptotes resulting from that solution. So let's just cross that out and move on to the next one, which again is a difference of two squares. All right, so that's a difference of two squares, which means we can break it up as x and x plus and minus 1 and 1. And that means we'll have x plus 1 is equal to 0 and x minus 1 is equal to 0. That leads to two solutions. The solutions will be that x is equal to negative 1 and that x is equal to positive 1. And those are actually the equations for our vertical asymptotes. So at x equals negative 1 and x equals 1, we'll have vertical asymptotes. So there's the equation for our vertical asymptotes. Now, for the horizontal asymptotes, we have to follow a simple rule. And that rule can be found over here in green. The basic idea is simple. We're going to look at the degrees of the numerator and the denominator's polynomial. If the degree on the top of the function is smaller than the degree on the bottom of the function, we're dealing with the first case, where n is less than m, or in other words, we have the small degree on top of a larger degree. When that happens, the horizontal asymptote is simply the equation y equals 0, or in other words, the x-axis. And it's that simple. We can only have one horizontal asymptote. There can't be two horizontal asymptotes in a function, so basically y equals 0 is the only horizontal asymptote. We have two vertical asymptotes, and those are the asymptotes for example A. Let's look at part B then. Okay, for part B, we're going to do the same thing. We're going to set the denominator equal to 0 in order to find the vertical asymptotes, right? So we'll set those equal to 0, and that'll mean trying to factor in this case. So let's try 3x and x for the first term, and then for 8, we got to think of possible factors that may work here. So we can try, for example, 2 and 4 if we want. So let's try, for example, 2 and 4 like that. Then we get 4x and then 6x, right? Now they don't subtract to give you 5x, so that won't work. If we flip them around and do 2 and 4, then we get 2x and 12x. Again, those don't subtract to end up giving us the middle term, 5x. They subtract to give you 10x, so that won't work. Don't forget, we know that we need to subtract because of the negative here on the right. So 2 and 4 don't work. The only thing we're left with then, of course, is 8 and 1. And if I put the 8 here and the 1 here, that should work out for us. So we'll have 8x, and then 3 times 1 is 3x. If you subtract 8x and 3x, you do indeed get 5x. We just need to make sure the signs are appropriate. Remember, if we have a negative on the right, it means a sign of each in the parentheses. So let's go ahead and make it negative 8 and positive 1. Then when we check the terms, we'll have what? Negative 8x, and then positive 1 times positive 3 gives you 3x, and the difference between those two is negative 5x. That's our middle term. So we have factored this. Then from there, set those factors separately equal to 0. So 3x minus 8 is equal to 0, and x plus 1 is equal to 0. We end up getting that 3x is equal to 8 from that, and then dividing both sides by 3, we will get finally that x is equal to 8/3. Remember, that's our vertical asymptote there, right? And then if we do this one, we get x is equal to negative 1. And that is our second vertical asymptote. So this equation, just like the last one, has two vertical asymptotes. Okay, let's try to find the horizontal asymptotes next. The horizontal asymptotes will follow this rule again that we have written here, which basically says that we have to look at the degrees of the polynomials that make up the numerator and the denominator of the rational function. All right, well, let's look at the degree for this pair of polynomials, right? it looks like both of them have degree 2 because the highest degree term in both polynomials is x squared. Now, if that's the case, then we have a very easy rule which says that the horizontal asymptote will basically be determined by this little rule, which says that it's the ratio of the leading coefficients. In other words, it's the numbers out in front of those leading terms that will end up forming a fraction that represents our horizontal asymptote. So that means we'll have y is equal to 2/3, right? So we just take the numbers that are right out in front here and make them into a fraction, and then say y equals to that is our horizontal asymptote. And that's it for this problem.